Example 4 in section 1.3 deals with simplifying and evaluating using function notation. Okay, so function notation should be something you're familiar with. This reads f of x equals 3x squared plus 2x minus 4. This one's h of x equals 5 minus 4x. It doesn't mean h times x. It doesn't mean f times x. It means this function is a function with the variable x in it, and they're calling this function f. They're calling this function h. That's all it means. So when they want you to simplify the following, all of these things should be things that you're fairly familiar with. F of negative 2 simply means, hey, take the negative 2 and plug it in for the x's in the f function. So this is really 3 times negative 2 squared plus 2 times negative 2 minus 4. And then you just evaluate it using correct order of operations. So negative 2 squared is 4. 3 times 4 is 12. 2 times negative 2 is negative 4. And negative 4 again comes down. 12 minus 4 is 4. So I would write f of negative 2 equals 4. Done. And it's as simple as that, just plugging things in when they give you a number plugged into a function. When they want this, h of f of x, it's the same type of thing, but notice on this one they want negative 2 plugged in for x. On this one they want the f function, the entire function, plugged in for the x in h. So I'm going to take the whole f function, I'm going to plug it in for the x in the h function. So f of x, h. So they call this h of f of x. So my h function was 5 minus 4x, but instead of the x, I'm going to put the whole f of x function. So 3x squared plus 2x minus 4. Okay? Then I'm going to just do a little bit of algebra to clean this up. So this is going to be 5 minus 12x squared minus 8x plus 16. I have two like terms I can put together. 5 plus 16 is 21. So this is negative 12x squared minus 8x plus 21. And this is h of f of x. That's all there is to it. You just plug it in, simplify it down a little bit. This notation, this f and then this o thing, it's the same thing. This means f of h of x. You'll just see it written in a different way. It's the same exact thing though. So this time they want me to plug the h function into the f function for all of the x's. So this is going to be 3 times the h function goes in for the x's. So this is 5 minus 4x squared plus 2 times, there's another x, so I'm going to plug it in again. 5 minus 4x, and then just the constant of the negative 4. So again, we're going to simplify this down some, but you'll notice this one is squared. One of the biggest issues that people always run into is they try and take the 3 and they distribute it in before they do the squaring. PEMDAS says you do exponents before you multiply. So we have to go ahead and do the FOIL on this one. So if I've got 5 minus 4x squared, 5 minus 4x squared, if I FOIL that out, I'm going to get 25 minus 20 minus another 20, so minus 40x plus 16x squared. If I distribute in the 2, I get plus 10 minus 8x minus 8. Oh, nope, minus 4. That 2 doesn't distribute to that 4. What am I doing? Okay, so the negative 4 just comes down. You'll have to excuse that terrible handwriting. You'll figure it out. Okay, the 3 then can distribute it in. So this is 75 minus 120x plus 3 times 16 is 48. So this is 48x squared plus 10 minus 8x minus 4. Okay, combining like terms, I've got 75. That can go with 10. That's 85. And then minus the 4. So 85 minus 4 is 81. I've got negative 120x and negative 8x that go together. So those guys give me negative 128x. And then I just have this 48x squared left alone. And we should probably write it in the correct form. So let's write f of h of x equals, remember we write them in descending exponent order. So the x squared comes first, plus 81. So this would be f of h of x. Or you could have written it this way. Either one is the same thing. Let's see if I can squeeze letter D in here. I think I probably can. It looks like it's going to be pretty small. Okay, so you'll notice there's a couple of different weird things going on in here. It looks like they plugged the -1 into the f function and then squared it, and then whatever they got, they plugged that into the h function. Okay, so let's take this in a couple of parts. I know I need to plug -1 into the f function. So let me plug -1 into the f function. So that means I'm going to have 3 times -1 squared plus 2 times -1 minus, can't really squeeze it in here, let's put it below, minus 4. So that's just the -1 plugged in for the x's in the f function. Okay, so f of -1 then, this is what, 3 times -1 squared, so this is 3 minus 2 minus 4. Well, 3 minus 2 is 1, minus 4 is -3. So f of -1 is -3. Now they want me to square that. So f squared of -1, if I square the -3, I get 9. Okay, well that wasn't so bad. And then this f squared of -1, this 9 that I got, is what they plugged into h. So h of 9 is 5 minus 4 times 9, and 4 times 9 is 36, so this is 5 minus 36, so h of 9 is -31. So h of f squared of -1 would equal -31. So you could write it this way, or you could write it that way, because they're equivalent, all right? Hopefully that made some sense. And that's how I always like to do those, just kind of following them step by step. I know I need to plug -1 into f, I know I need to square that, then I'm going to take that and plug it into h, so that I don't have to do all of the math all at the same time. All right, on this bottom section, we're going to get to things where we're just plugging in the x's. So this notation again is the same notation as we had up here, f squared of -1. The difference is we're just going to take the h function and we're going to square it. So the h function was 5 minus 4x. So if h of x is 5 minus 4x, then h squared of x should be 5 minus 4x squared. And we can FOIL that all the way out, but since we're not using it for anything, I don't feel any need to do any extra work. So we're not going to do that. Look at E. E is a little bit strange. So up here we did h of f of x, so we plugged the f function into h. In this one, if I work my way all the way in, I'm going to plug the h function into the h function, and then whatever I get, I'm going to plug that into the h function again. Okay, so let's start at the beginning. So I've got this h function right here, 5 minus 4x. And I'm going to take that h function and plug it into the h function. So h of x. So if I plug this into itself, and I'm only going to plug it in where the x's are, I get that. Well, this is going to be kind of gross to plug in, so let me simplify this down a little bit. So we'll call this 5 minus 20 plus 16x. So 5 minus 20 is -15 plus 16x. So this is h of x. So that's this part. h of x. And I'm going to take that and I'm going to plug it into the h function again. Well, the h function was this. So if I plug this in for the x, h of x, because that's not confusing, is 5 minus 4 times -15 plus 16x. Well, that's not terrible. So this is 5, -4 times -16 is positive 60, and -4 times 16 is -64x. So h of x, gracious, is 65 minus 64x. So again, it's a little bit more complicated, but it follows the same pattern and it makes, I feel like, mathematical sense as to what it is that we're doing. This function goes to that function, the whole goes into that. So that's how we're going to kind of work this. Look at G. We've got x plus h getting plugged into the f function minus the original f function. So this is the original function. And then we're going to divide whatever we get by h. Okay, well, if I plug x plus h into the original f function, that's going to give me 3 times x plus h squared plus 2 times x plus h minus 4. so that's f of x plus h, this right here, minus the original f function. And since the original f function has more than one term, this minus is going to be distributed in and affect all of those terms. So I'm going to put parentheses around it just so I don't forget to do that. Minus 4. And that's all over h. Okay, so I feel like I can probably put some of these things together if I were to distribute and FOIL them out and combine like terms, okay? So x plus h squared, I know you're not necessarily used to doing FOILing with no numbers at all, but it's going to follow the same pattern. So if I FOIL this guy out, let me keep the 3 for now. If I do x plus h squared, I'm going to do x plus h times x plus h. So x times x is x squared, x times h is xh, h times x is xh, so I have 2 xh's plus h squared. Plus, let me go ahead and distribute that in, 2x plus 2h minus 4 minus 3x squared minus 2x plus, let's squeeze it in there, plus the 4. And all of that is over h. So I FOILed this out, kept the 3. I distributed the 2, kept the negative 4, and distributed in that minus so that I changed all the signs of those back terms. All right, so next up, distribute in the 3. So 3x squared plus 6xh plus 3h squared plus 2x plus 2h minus 4 minus 3x squared minus 2x plus 4. There he fits, barely. H. So there's just a little 4 right here. Hello, 4. Okay. Then 3x squared and negative 3x squared are going to cancel. Positive 2x and negative 2x are going to cancel. And negative 4 and this positive 4 that's hanging out on the very edge of my paper here, those are going to cancel. So that leaves me with 6xh plus 3h squared plus 2h over h. And you'll notice that this h is now going to cancel with all of the h's that are in the problem. So if I divide them all by h, this part turns into 6x, this part turns into 3h, and this part turns into 2. So f of x plus h minus f of x over h is really 6x plus 3h plus 2.